All right, hello there. We are going to look at section 3.3 today, and we're going to split it up into two parts. This is the first part of 3.3, and we are going to learn how to evaluate limits when we don't necessarily know what the graph looks like and have some strategies for us. So for instance, the first one is a limit for the graph x as x approaches 2. Now remember, if a graph is continuous, or in other words, there's no asymptotes, no holes, it's not a piecewise function, you're just finding the y value. So to find the y value when x is 2, you plug 2 into the equation, in this case just x, so the answer is going to be 2. That as the x value approaches 2, the y value will be the same. For question B, it's a constant function no matter what, it's always going to be 19. For this linear function, x plus 3, we put in 4, the y value that goes with that is 7. That's the y value when x is 4. And similarly, even for a rational function, such as question D is, you replace it with -1 and you're going to get 0. If the graph is continuous, you just plug it in. And if you have an idea of what the graph looks like, you're going to feel even more confident doing that. Let's take a look at another one. You'll notice that this question is a left-hand limit. We are looking at the left-hand side of -1. So what does that mean for us? Well, we're still going to plug in 1 and see what happens. When I plug in 1, I get -1 plus 3, so 8 minus 1 is 7. If you put 1 into the bottom, you get 7, you get 1. The graph is continuous at 1, whether it's on the left-hand side or right-hand side, you're going to get the same result. Either way, and again, just another one, just plug it in. -3 is -1 times -8, so the answer will be 8. Now, not all questions are going to allow you to substitute, so let's take a look at this example. When I put in -4, we get 2 over 0. And we would say, therefore, that is undefined. And undefined leads us to vertical asymptotes there. And so we're going to have to get a picture of what happens on either side. So when I consider the factors x plus 6 and x plus 4, and then do my sign analysis, we have 0 at -6, undefined at -4. So what this sign analysis will allow me to do is to look at the left-hand side, because we're looking at a right-hand side. We're looking at a right-hand limit. What happens on the right-hand side of 4? Well, this plus sign tells me we're going to be positive. The asymptote tells me we're going to go to positive infinity. So we would say that the limit as x approaches -4 from the right-hand side for the function, if you don't want to rewrite the whole thing, you can just put in f of x, will be positive infinity. It's going to go up forever. And we can do that for all these. If we answer it on the left-hand side, which is right over here, we see that it goes to negative infinity, which allows us also to review that what does the limit actually exist at -4? And the answer is no, because on one side it goes to plus infinity, on the other side to negative. Now we would do the same strategy when you look at this question right here. We would do a sign analysis and determine what happens on the left-hand side of 3. The big thing that I would like to see you do is the substitution. You put in 3, you get 3 over 0, and then I want to see this work shown, and then do your sign analysis after that, just so that you understand it's undefined, because we will be dealing with indeterminate right away. So again, the main thing I want you to start with, direct substitution. I get -3 over 0. That is undefined. And then we go and we do a sign analysis. The other strategy that we can run into is after we directly substitute. So I'm actually going to factor this one first to make my life a little easier. You can see that when I plug 6 in now, I'm going to get 0 over 0. So that's not undefined. That's indeterminate. I'm just going to abbreviate that. So that means there's a hole at x minus 6. So these are going to cancel out. And once they cancel out, I'm sorry, there should still be a limit expression right there. Once they cancel out, I can replace 6 into the equation. I get 6 minus 1 over 6 plus 6, which is 5/12. and that will be the limit. And if you just think of what this graph is, this is a rational function, and if we do our sign analysis, it has zeros at 1, so we put a dot at 1. The graph would end up looking like this, and we're looking for the limit as x approaches 6, which will be way out here, and there would be a hole at 6, but it would be continuous otherwise. So as it approaches from either side, it still exists. And that's your strategy that you're going to run into in all of these assignments. You got to factor first, and here the big thing that I'm looking for is factor first, but because you haven't substituted in a value, you need the limit expression to carry with you. So you get x plus 2 times x plus 1, and we got our SOAP rule. So that should be a 2 right there. These cancel out, and now when I replace it with minus 2, I will get minus 2 plus 1 over minus 2 squared, which is 4, plus 4, plus 4, which is minus 1/12. And so you're going to have to go through some factoring, and as I walk around and see your work, I'm going to check and see your notation is okay. So you're going to work on that assignment, and then we'll get to the second part after you've done that. So talk to you again soon.